I hope you all can see my screen. So the first topic we are going to discuss today is about DHCP. So we all know about this DHCP process a little bit, but let me give an overview about DHCP first. Let me fire up my whiteboard. So when this is a client PC, and this is a DHCP server, and mostly the conventional design in the enterprise would be there is a switch and the users are connected to the cabins. There's a patch cable that's running from the switch inside the server room. So the user will be connected. They should have a wired connection here and they are connected to a port. And if it is a small office, they would have this local DHCP server setup. And if your DHCP server is somewhere in your remote site, example, this is your headquarters, and you have a switch, and you inside the server room, you have a switch and you got your DHCP server connected here. So your location will be connected something like this. So this is your branch office router, and they say this is an head-end router where you get your internet access. So example, this is a cloud internet and you are connected like this. So most of the deployment, they do this centralized DHCP deployment. Why? It is quite easy. It's very, from the network engineer standpoint, this is pretty simple to manage. So management is very smooth when you do this centralized DHCP deployment, because I cannot have a DHCP server in every location. So this is one location. So example, you got one more location somewhere here. This is your remote office, and you got your router and same kind of setup. You got a switch and you got the DHCP server connected here. So this is all local. This is all local servers. So here, what we are going to look at today. So how exactly the DHCP works, and through Wireshark, how do I capture those packets? Okay. So it can be done either way. Either you can do from the switch or from your PC. So example, if this is your PC, this is the PC, and you have your network interface card, we call as a NIC card, where all your traffic is going to the switch and all the way back to this DHCP server. So imagine you have your DHCP server, local DHCP server here in the switch. And if your communication is happening between this PC and your DHCP server. So the PC is going to send a DHCP broadcast. So we call this as a DHCP discover. If you look at the IP header, it's all zeros. If it is all zeros, it means everything. No limitation with the network. It's broadcasting out. And your subnet mask will be 255.255.255.255. Why you're going to this level? Only then you can find out the DHCP values, and you can differentiate the discover packet, offer packet. So to make the differentiation, you should be aware of all this. So your packet form is it looks similar to this in the DHCP broadcast, and now the DHCP broadcast has been sent from the PC to the DHCP server. So what if I send a DHCP broadcast and I'm not getting a response back from the DHCP server? How do I find that? Only with the PC, if you do a DHCP discover, you will never find anything out of it. All you can do is DHCP release and DHCP renew. That is something I'm going to flush my IP and I'm trying to discover back again. This is DHCP renew will initiate this DHCP broadcast packet back. So this two communication happens with the command line in your PC. In your command line, you can do ipconfig/DHCP release and DHCP renew. In your IP config, you can do DHCP release and DHCP renew. So only this is the limitation I have with my PC, and I can do it. So if I'm not getting a DHCP, how do I find it's a problem with the client, or it is a problem with the server? So this is when the Wireshark comes in. So we'll see how we can figure out, is it a problem with the DHCP server or it's a problem with client? So for that, let me open up the DHCP packet capture. Okay, so here you can see my source address is all zeros. My source IP is all zeros and my subnet mask is all 255. So if I go a little bit right hand side, I can see the communication here. The info, it says it's a DHCP discover. So it always happens from the client. This is your PC, your DHCP discover will be from client. So now let's drill down inside the packet. See, DHCP stands for Dynamic Host Configuration Protocol. So your client IP address at this point, it is all zeros. And if you see the boot flag, this is unicast. So we'll get to know about all these details because of Wireshark decoding. So you can see the list of options here, and the main options, what we should focus here is what is the client IP at this point? This is all zeros. And this is a DHCP broadcast. Can you see this is our DHCP broadcast, and this is, we say this is L2 broadcast. So all F is an L2 broadcast here. So this is done. So now the client, it sent a DHCP discover packet. It's a broadcast for everyone. So whomsoever in the network, they are interconnected inside the LAN. Yeah, this is how exactly the DHCP process works. This is your switch, and you have many clients connected, and you have your DHCP server here, and the DHCP protocol is enabled in this server. And this is all clients. This is all client PCs. So from this client, the DHCP discover is broadcasted. It goes to all the clients in the network. This broadcast goes to all the clients in the network. But the DHCP server will respond back. Why? Because I have created a scope. We call this as a segment. Example, all this PCs or in this particular IP range, 10.0.0.0/24. Yeah, this is my subnet mask and this is my IP details. So I want to get an IP from this range. So what should I do here? So inside the DHCP server, it should have the IP parameters. What are the IP parameters it should have? It should have a scope for 10.0.0.0/24. So it's going to define, okay, my IP is 10.0.0.1 to 254, and 255 is my broadcast. So 10.0.0.0.255, this is a broadcast address. So it starts from 10.0.0.1 and it ends with 10.0.0.254. So you got 254 address inside this scope that's configured here. But now the question is how this client knows where the DHCP server is. Whenever the DHCP request it goes, it actually, we call this as gateway address. When you send a broadcast, so for example, all these clients are connected to this switch, and this switch is the gateway for all the clients. And my gateway has been configured as 10.0.0.1. So what happens, all this broadcast, it hits the default gateway. From the default gateway, the packet will be traveling back to the DHCP server and it look for the scope. Okay, it matches my network and I got a scope and I got an IP address, and it picks an IP address from here, a random IP address from here, and it will reply back to the client. And now the client gets an IP address. Now the client gets an IP address back from the DHCP server. So this is the offer packet where if you look into this, you will see this is boot reply. This is a reply from the server. This is an unicast again. Even at this point, the client IP address has not been assigned, and it's giving an IP address 192.168.0.10 because this is my PC, and the broadband, it uses a class C address. This is a class C address. There in the example, I have given a 10 network. So this is a class C address, and it says this is your next server IP address. And you will see your MAC address details. At this point, it's saying that, okay, if you are okay, you can get this IP details for you. Even at this point, the client has not been assigned with this IP address. It is just offering this IP address to the client. So you can see all this information inside. So now the server has been successfully sent the IP address to the client. Right? So request is again from the client to the server. This is again a boot request. And if you drill down, if you see the client has not gotten any IP address details. And if you go back to the DHCP acknowledgement, here actually the PC, it gets an IP address. So now the client got an IP address. So this is called as a four-way handshake. So why Wireshark is needed here? So if there is a problem between a client or a server, I can figure out. If I see the DHCP discover, and if I am not looking any DHCP offer packet, then I can conclude that it's a problem with the server. So this is a real advantage of using Wireshark for DHCP process. So if there is any problem irrespective of anything, if you're not getting your DNS details, if you're not getting your DHCP IP address, you can figure out where is the problem. It is a problem with the client, or it's a problem with the server, or it's something with the scope. Yeah, this is just a glimpse about how DHCP works. This is a demo class. So in the real classes, we'll drill deep and we'll do a deep analysis about every single parameter of DHCP in Wireshark. So this is all about DHCP process. So now let's jump on few filters. So example, if I don't want this particular destination IP address in my packet capture, how do I do that? So this exclamation stands for not, and this is IP.destination equals and your IP address. This is something I'm not interested to look at any kind of conversation that's happening for this particular IP address. Let me copy this filter and let's assign this. So if you actually see, if you drill down, you won't see this IP details 192.168.10.185. That's the meaning of this. So IP, whatever the IP with this destination, this particular IP, I'm not interested in. I don't want to see any kind of conversation for this particular IP. So this is the use of not operation and followed by your IP assignment. So if you give IP dot source, you will not see any source address with the parameter. Whatever the IP address you want to give, if you give here, it will filter out all the IPs with the source address. Now I have given destination. So this is one filter. The real classes will see 100+ filters that can be applied based on your issue. You can figure out what exactly needed. You can filter out all the other details, and you can look at exactly what exactly needed for a particular issue. You can filter out if you tweak your Wireshark filters. So next thing, what is ether type? About ether type, you maybe in many interviews I heard, and even I've been questioned about what is ether type, what is the use of ether type, and why we use ether type. Ether type is very important because when you look at this is a little bit of overview about the OSI model. We are not going too deep about OSI. Just for this ether type, I'm going to give a little bit of background about ether type. So when you look at the last layer, it is physical layer. So after that, here you got network layer. This is layer 2, where all your MAC address. So this is called layer 2, right? This is called data link layer and layer 2, and this is your layer 3, and this is called L1, all signals. You get only the wire connections connected. It's all understand about the signals, nothing else. So when you look at this data link layer, it's all about MAC address, right? Destination MAC first, example CDE4, for example, and your source MAC is something similar to BCDE. So what is ether type and why I need to know about ether type? So ether types defines what is my next packet. Is it an IP packet, or it is an ARP packet, or it is a DNS? So when you do a troubleshooting, so where the problem is it my DNS communication is not happening, or if it is my ARP communication is not happening, or it is something problem with IP? You have no clue. If you do not have any, if you're not capturing the packets, you'll never get to know about all this. But with Wireshark, if you go back here, and if I take any IP address here, you have to click on any IP inside the internet protocol. You have the ether type, but it's very hard to find, right? So it's very hard to find where is my ether type. So there is a filter in Wireshark where you can find the ether type. So if I copy this, this is not equal to ether type 0/0x0800 for every, as I said, for IP, there is a different ether type value. For this is 0x0800 is the ether type for IP. So if I want to filter only this, if I want to filter only this ether type, only the IP packet, I can use this. So this is all the IP packets I got. So ether type, you can filter all the ether types with the help of this filter. Ether type is all IP ether type. For ARP, you have a different ether type. And so in the real class, you will see how if a DDoS attack is something, if they do a continuous ping to your PC, that is choking your bandwidth, they will bring down your server. Example, if you got an environment where you have multiple clients connected, and somewhere from the internet, an user, he's trying to do this DOS attack. It's a continuous ping attack they do to bring down this server. They can do this with the DOS attack. So with the help of Wireshark, with geo-IP configuration, you can find out where you get a list of hits. What is the IP range and from which location, from which country you get this attack. You'll get to know about all this in the real classes. We have a topic to be discussed for this, how the DOS attack is happening and how can I find with Wireshark. I'll just show you how it looks. So for that, you have to install a application as a geo-IP, and we can configure the Wireshark to utilize it, and you can find out, okay, where is my IP it's coming from the scan map. And you can find, okay, this is a list of IP range, and this is the location, this is the country I am getting hits from. So you will get to know about all this. We have a lab for it. And this is how the Wireshark works. When it comes to, if they do a vulnerability analysis, and if somebody is trying to do an attack, you can find attacks. And this is one demonstration we have in the real class. We'll see how this DDoS attack is happening and how do we figure out that, and how with the help of Wireshark, how you can find out where to find and how to configure. Since we had a long discussion yesterday, I just want to give a glimpse about some of the topics in Wireshark. So now I'm going to open up the course content we are going to cover. I'll give you a quick overview about the course content here. So in the Wireshark class, for the first lab we'll help everyone to install Wireshark, and we'll walk you through Wireshark hands-on and what are the profiles that can be used in Wireshark, and configuring profiles, adding custom columns. Example, if I want to make this as a fill column, if I want to apply this as a column, and I can apply this as a column. So very quick use of this column. Example here, identification. For every IP, there is an unique identification number. Example, if you come down here, if you see this is 192.168.0.38. And if you see from here, for all these IPs, can you see the identification number, IP identification number that's going to be unique for every single transaction between the server? So it means from this, I can figure out, okay, my communication is successfully happening between source and destination, and my identification number is always incrementing by 1. And this is all the random number that's been assigned by the operating system. And I'll tell you, for some servers, for developers, they want to hide their information. If we are tracking that, they may feel this is that is a security breach. Some servers, they can hide this identification number that can also be 0 at times. That depends on the developer, the application, what we use. But from this, I can have a quick track about, okay, my communication is actually happening to the server. And if you're getting a different, if you get a random number from the server, it means that it is busy and it is talking to other clients. So from here, I can understand, okay, the server is really busy and I have a connection to the server. There is nothing problem with the server, maybe something with the client. So we'll get to know about deep understanding about this IP identification. This just for demonstration, I have shown this. So we have a topic of IP identification. Likewise, we got, deep explanation for every single topic we discuss here. And we see the coloring traffic, how we do a coloring and adjusting the screen layout and configuring the Wireshark interface. Right, you can select the interface when you fire up your Wireshark. You can select the interfaces, the actual interface where your actual traffic is going. You may have multiple interface, but where is my traffic is going? Now it's going on my Wi-Fi. So how do we specify that, and how we capture traffic on a specific interface? And introduction to Wireshark filters. We have different filters for IP address, source, destination, protocols and numbers. HTTPS, it uses 443. Likewise, for we have different option filters. We'll look at every single filter that's possible filters that we use in Wireshark. And we use operators, as we see here. It's a not IP.destination. And the combination of packets will be added with IP.address and IP.address is something like I'm using source and destination. So I have to give something like this. So I'll give IP.address equal and the IP address 10.0.0.1 and IP.address equals 8.8.8 for google.com. So you'll do all this. It's a one example. So likewise, we use different operators here. And we'll create a display filter. This is all display filters we have here. This is called as display filter. And how to capture in a switch environment. Example, if you're working in the enterprise and you want to do a span port, if you want to offload your traffic from your switch, how do I do that? So you'll understand everything. We'll do a demonstration. I'll do a lab for it. So example, if you got a switch and this is your switch and this is your PC where you're logging to your other switches in your enterprise. And if you want to offload this traffic, the traffic that goes to the trunk interface, and how do I offload this traffic back to this PC? So this particular port will be made as a span port. It will be in monitoring mode, and all your traffic will be asking for your destination port, source port and destination port, both you have to define. So this is your destination port and this is your source port. So I'm going to offload all this traffic from source port to destination port. So what happens inside your Wireshark, you will see all the traffic that is actually going through this trunk. Actually, the traffic that is going through trunk will be captured inside your Wireshark. So I'll do a lab for it and we'll check the protocols, every single detail inside. And I have given so many topics here. So we'll see OSI model, step by step, every single packet, Ethernet header, because we should know about Ethernet header, because if there is a cyclic redundancy check error, if there is a problem with your cable, so error keeps increasing. So how do I find that? So we'll see what is inside the frame header, every single parameter inside the Ethernet header. Then we'll differentiate how we can differentiate unicast, broadcast packets, multicast packets in Wireshark. And this is about the layer 3. So analyzing multiple capture points, and analyzing a packet, digging deeper into your IP ID. We define, right? That is identification number, digging deeper into IP ID, how to use the TTL field. As I said yesterday, TTL is very important, and where you can, find is it really the routing is happening or not. If your TTL is not decrementing, then there is a problem with the routing. So how this IP fragmentation works, and IP flags, and you'll see about IPv6. And as I said, configuring Wireshark to find geo IP locations to mitigate the DDoS attack. Then in the URL practical, UDP practical, you will get to know UDP is more with this video streaming. So you will analyze DNS and how this UDP is used by all this application, DNS, DHCP. So we'll see what is the header value, how DHCP works, and how do I troubleshoot that. So we have a lab and troubleshooting VoIP and video streams. And we will do the hands-on with the TCP flags and list of options we have for TCP. And yesterday we saw what is sequence number, acknowledge number, how it works, and digging into retransmission. Why retransmission happening? It's because of routing loop, or it's because of the server is not responding. So what is fin flag? What is reset flag? And you will come to know, is it a client, network, or server? These 3 are the possibilities. So in that we have a lab for every single topic and a TCP analysis. So most of the application, they use TCP. So we'll find how the slow application response time, you will find out high network latency, network packet loss, slow file transfer, and network application disconnects. TCP reset happens because of that. Yeah. So all the topics, for every topic, we have a lab. If you look at this UDP, you have a lab for UDP. See, this is all labs. TCP lab analysis. This is troubleshooting labs. And for every topic, we have a lab. For all the topics, whatever we discussed, we have a lab. So this is about, a brief overview about the Wireshark course. So let me unmute now so you can ask your questions. And you can unmute yourself and you can ask your questions. Am I audible?
Yes.
Okay. Anybody have any questions about the course content or about the course? You're most welcome to ask your questions.
Hi, sir. Is there any recording available for class 1? Yesterday class?
I think, yeah, we should have a recording for class 1.
Is it available on app?
I'll let you know shortly. I'm not sure. I mean, it's recorded and we have, and I'll talk about how we can share the recording.
Thank you.
By end of this class. Yeah.
So Arjun, this is Venkat. So this 2 days class is covering entire Wireshark, or in your lecture you said your some real-time classes are there?
No. This is just a demonstration, and this is just a webinar about giving insight about Wireshark, how it works, how we apply filters, because most of them maybe they might not started their profession with Wireshark, and they may not be working on networks a lot. So the intention is to give a glimpse about Wireshark and what is the use of Wireshark, and how do we do capture, and how exactly it works with the networking protocols, and
Okay.
how we can do the filtering and capturing.
Okay.
So
I just one question. So can you just explain the retransmission with the help of client and server?
yesterday we discussed about the retransmission, right? Let me.
Yeah, I was having some doubts. So
Okay.
no, basically how the retransmission is happening, because
Okay.
of what reason?
Then let me open up the capture.
Mhm.
So yes, here. Duplicate acknowledgements. Let me take this. Yeah. Tell me, yeah, we can look at the TCP duplicate acknowledgements. It's similar to retransmission. Yeah.
Okay.
Yep. Your question?
Basically, I just want to know because see, when we have the client and server communication, right?
Yeah.
And so if just correct me if I'm wrong. For example, when we are sending a packet, okay, you know, we will be for every packet whichever we are sending, we should get the acknowledgement back from the other device, right?
Yeah, that's right. Yeah.
So if we are, as per my understanding, if I'm not getting, if for example, I'm sending a packet, I'll be having some timer on my end. If I'm not getting the acknowledgement back, okay, from the peer within a time, then only I'll go ahead and retransmit the same packet, right?
Yeah, that's right. Yeah.
Okay, if that is happening, how we can see, because yesterday I believe you are saying, we have client A and the server B. Okay, if the client A is retransmitting the packet, as A was not getting the acknowledgement back from the server B, we should troubleshoot that, right? Instead of we should focus on the retransmitted device.
Sorry. The final part, what did you say? I don't understand.
No. See what I'm saying? I have client A and B. Okay, for example, I have sent the packet to B. Okay, I'm waiting for the acknowledgement for the some time. I didn't get that one, so the client A has retransmitted the same packet, right?
Yeah, that's
okay,
right.
now, yes. In that case, we should troubleshoot why the acknowledgement, we didn't get back from the server, right? That's where we should troubleshoot, right?
Yeah, exactly. Where the connection broken and where exactly we started this, we started seeing the retransmission. That's when your problem starts, and there is exactly the problem is when exactly the retransmission
That's what the
happening.
confusion. Yeah, that's what the confusion, because for packet, if you are looking there will, on the Wireshark, there will be source and destination, right? For example, I'm seeing continuous, retransmission packet from the client. That means I'm not getting the acknowledgement packet from the server, right? So in that case, how we can, we can tell the client is making the problem.
See here, what is the source? Who is sending this TCP duplicate acknowledgement? So it's sending, it's a client, right?
Exactly.
So this is a server. By looking at it, we'll know, okay, this is a client, and it is completely, it is keep on sending this duplicate acknowledgement. And see, you can see it's filled up a lot. So it's a problem with the client. And we have to figure out from there why it's happening. It's because of routing, or it's because of latency, or it's because of the server. So we have to, but we got a clue, okay, where exactly the problem is. It's a client or server. That's the first catch. Then you have to drill down about your issue. Yeah.
I got it. I totally understand that point. But logically, when I'm thinking, the packet and the acknowledgement, see, it is sending because it didn't get the acknowledgement back from the server, right?
Yeah, that's right. Yeah.
Yeah. Then we are going to drill down, the issue on the client, and that's what the confusion is happening for me.
Yeah. Because if you see, you can do this. If you follow this, not following the stream, if you see the conversation filter, and if you do a TCP, now you see the conversation only related to 192 and 104. So if you see here, so this is an intermittent issue. So from here, see here, it is the TCP handshake is successful. I see SYNAC ACK, and the TLS handshake happened, and your data is keep low. If it's going really well, and I'm just following the stream only between this source and destination. So if I drill down here, exactly the first problem started. Here there is a retransmission, right? If I look at it, okay, from here, I have to figure out, okay, from this point, there is no problem. So from here, who is doing this retransmission? Now it is from the server. Now it is from the server. Yeah, the server is retransmitting. Now here you got a clue. So it is retransmitting to who? The client. Yeah. And if you see your TCP out of order packets, that's happening for the client. Because this client is asking for the retransmission, right? This is not a server again. You got it what I'm saying? So the retransmission is happening from the server to the client. So again, it's a problem with the client. Because the client is keep sending this duplicate acknowledgements because it didn't get a specific segment from the server. You got it what I'm saying? So this is retransmitting back to this client. And if you see TCP out of order, and if you see that this completely the client, it keeps sending this duplicate acknowledgement. So here there's a server. If you see drill down, where is that? We saw that, right? A list of conversation where it happened between the client and server.
Yeah, I saw that.
Where is it? So see here, list of duplicate acknowledgements is happening between the, because here the client is a culprit and client is not, receiving the packet. Is something problem with the client when we have to figure out why. We have to reproduce the issue and we have to do the capture and we have to figure out. Yeah.
Hello, sir.
Yeah. Yeah.
Sir, what is the duration of this class?
You mean, yeah, well, you just contact to this number. We'll give all the details.
Okay.
It approximately, it will take 50 hours.
50 hours.
Yeah.
And sir, if any case, actually what happened, our switches are sometimes down. Okay.
Sorry?
And, in our environment,
Okay.
okay, so we have many switches. Okay, so sometimes that switches are down.
Okay.
So how we will just capture that? Exactly what happened that some devices send the broadcast. Many devices are there, all are Windows systems, and sometimes they are doing broadcast, and that's why the so switches hang. So how we capture that one? Is it any way?
No, switches, then if the switches is not responding, then you can do continuous ping to it and you can capture from your PC, right? Where the PC where you try to manage those appliances, you can do that.
We can capture that one. Is it possible?
Yeah, that is possible. As I told you, see, example, if the switch goes down, right? So if the switch goes down, example, let me open up this. Where's my whiteboard? See, as I told you, in the Cisco switches, you can do span port. Example, this is your PC. You have a wired connection back and you have your Wireshark here. The Wireshark is running, and if you make this port as a span port, and this is your actual traffic is going to a trunk to other switch, right? So
Yes,
if you are connected to this switch, you can offload all your trunk traffic. I mean, the trunk port traffic to your PC. through you have to specify inside your span configuration, you have to specify your source port and destination port. So when you give the destination port as your PC is connected here, right? So if the destination port is your PC, then all the traffic that is traversing between these two switches, you will see all this traffic, all the protocols inside your Wireshark inside your PC. Yeah, live capture. And you can save it later, and you can check it why the switch goes down. And it's all about depends on the specific protocol, right? If you're doing some VLAN config mismatch, or if it is your port channel, you can see the LACP communication, and you have more insights about every protocol. It's up to you then where you're interested to see. Okay, if your connection is breaking, it's something because of VLAN, or it's something because of a port channel. If you are giving, if your port channel should be, if you have a port channel connection between two switches, the VLAN should be similar. If there is a VLAN mismatch, your port channel will be broken. So you will see the LACP is broken because of VLAN mismatch, or why it is broken. And you will get to know all these details when you offload this traffic back to your Wireshark and you do an analysis. This is one typical example I am giving. So it depends upon your scenario, what is the issue you're facing and which protocol you want to see.
Okay, sir.
Yeah, hi, Prem here. Could you please explain about the spam configuration, spam configuration?
Okay. So spam configuration is, okay. You got a switch and you have a hardwire connection with your PC. And this is an uplink connection to your switch. So what I'm saying is, so inside the spam configuration, you can specify your source port and your destination port. And there is an option for your VLANs also. Only if you want to capture a traffic for a specific VLAN, you can do, or you want to do all the traffic, you don't need to specify your VLANs. You have to define your source port and destination port. So once you configure this spam configuration, the port goes to monitor mode. And it starts to monitor all your traffic. Now, how I can offload this traffic? I have to give the destination port. So if my destination port is something like GI0/2 and my source port is GI0/1, so all my traffic will be offloaded back to this port. And I should open a Wireshark. When I do that, and inside the Wireshark, you will see all the protocols like DNS, your DHCP, your UDP. And you have to look at what exactly you wanted from this, which particular protocol you suspect that it could be a problem with a specific protocol. You can drill down and you can find.
Can we configure the only as a source interface or destination in physical interface, or we can configure a logical interface like LT or interface?
No. That is not possible. I mean, logical interfaces, actually the real traffic is not going through the logical interface, right? That's just for communication. You have to specify the physical interface. Yeah.
Okay.
Because your actual traffic you have to offload, so you cannot do that with logical interface.
All right. Thank you.
No problem. Yeah. Any questions related to course content? You guys, if you have any questions related to the course content, you can ask questions, or maybe if you're welcome to ask any questions, but I'm saying if you have anything to be discussed or you need clarification about the course content or what we are going to learn, you can ask your questions. Feel free to ask your questions. I'm welcome to answer you.
Yeah, one more question. So what types of attacks in DHCP?
What? Sorry?
Types of attacks in DHCP.
DHCP starvation attack is the one I am aware of. DHCP starvation attack is the client keep on sending the DHCP request and the server will be giving all the IPs to the one PC Since as many DHCP requests I get, I'll give an IP back. That is DHCP starvation attack. So once the scope is completely utilized, so all the other clients in a network cannot get an IP address.
Mhm. Okay, and how I can mitigate that?
You have to do DHCP spoofing.
Okay, all right. DCP is perfect.
Yeah.
Thank you.
No problem.